So pre-calc exam A, we're going to go through a few of these problems some students have asked me to do for a video so you can see them at home. So question 4 on the exam review, difference of quotients. So here's our function f. This is the function f is x squared minus 2x. And so we're trying to find the difference of quotient for that function. And so I can break it in parts. We're asked to find f of x plus 2. So that's taking our function f and putting in x plus 2 in for the x values. So we have our function of f, which is x squared minus 2x, but instead of writing x in those two spots, I'm going to replace it with x plus 2 for both of those x's. And that's what's going in the blue circle there. Now we also are asked to have f of 2. So it's still taking function f and plugging 2 in for the x's. So if we do that, you get 2 squared minus 2 times 2. So if we write the difference of quotient with these two values, expressions in, so f of x plus 2 is all of this here. So I'm going to write that. And I can do some simplifying. So x plus 2 squared is x squared plus 4x plus 4 minus, if I distribute this, negative 2, so negative 2x minus 4. So that's all of this stuff. I've done some simplifying already. Minus, and then f of 2 is 4 minus 4, or 0. The whole thing is being divided by x. So that's really what the difference of quotient right here is we're trying to find, is the subtraction of those two f functions, or y values, divided by this x value. So if we simplify the top here, the 4 minus 4 is 0, and then we have minus a 0. So we end up with x squared plus 2x. We combine like terms all over x. And if we reduce that, we get x plus 2. So that would be the final answer. Now, this, if you remember correctly, when we talked about this, that this is describing our slope of our function at any given x value. So this is the difference of quotient. It's the substitution that usually gives students a hard time. So break it up in smaller chunks first before you write out the difference of quotient, and then simplify. Next problem. So using a graphing utility to graph this rational function, we want to find the domain of the function is really what we're trying to do, and then even or odd. See if it's even, odd, or neither. If I sketch what the graph looks like, it's a rational function. It's got this kind of like this inverse cubic shape here, but then it's also got two branches out here and right here. Now, if you take this graph and you spin it 180 degrees, you actually get the same graph. So I spin it 180 degrees around the origin, I get the same exact graph. And that alone tells me that it's going to be an odd function. So just with the rotational symmetry, I know it's odd. The other way you can see that is if you plugged in a negative value for x, you would actually get a negative function back to you if you simplify it. And that's how you can see it algebraically. Now the domain here is looking at what can the x values be. The domain, x can be anything except it cannot make this denominator 0. And so if we set the denominator equal to 0 and solve, x cannot be that. So x squared cannot equal 1. So if I square root both sides, x cannot equal plus or minus 1. And that's our domain. X can be anything, but it cannot equal plus or minus 1. So there's our domain, and we know it's also odd. 14. So this is using the equation our arc length equals our radius times our theta. Now our theta has to be in radians. Theta has to be in radians. And then we're asked to find s. S is the outside arc. And so the measure they give us, the 53, is this portion. And so we need to do is figure out our angle for s, or center angle here, central angle. So if I do 360 minus 53, I find that 307 degrees is actually the central angle we want to use. So I need to take 307 and I need to convert it. So it's like pi over 180. And so 307 pi over 180 is our radian measure, and that's what we're going to plug in here. So our arc length is our radius, which is 4.51. It's kind of hard to read that, I know in your review, times 307 pi over 180. You punch that in and give me a decimal approximation. If you do that, you get about 24.165 inches would be the arc measure. So just make sure you're in radians when you use the formula for arc length. Okay, some right triangle trig here. We've done this problem a few times. We've done it for the Statue of Liberty problem on your Chapter 4 test. We did it with the height of the steeple on your review or in the homework. So we've done it a few times. Here we're trying to find what is the height of the shorter building. So we really want to know this height, x. Now you need to find some triangles in here, and there's two triangles you should see. There's this blue triangle, and this blue triangle has an angle here of 63. We also have this green triangle, which has an angle of 33. And so that'll help us find two measurements. I'll call big H for the blue one, the big height, and then the little h for the height between the big and small building. If I subtract those, I'll actually find the height of the small building. So to find them, I'm going to use my right triangle trig. Given this angle 63 here, this is the opposite side, and we know the adjacent. This is also 40 up here. It's written down here, but it's equivalent there if the buildings were vertical. And so opposite of adjacent is tangent. So we have tangent of 63 equals big H over 40. So multiply both sides by 40, and we're going to find big H. We do the same thing to find little h. So it's going to be 40 times tangent of 33 is going to be little h. And then we're going to subtract those two measures. So we get 78.504 for big H, and we get 25.976 for little h. And then you're going to subtract the two to actually find the height of a little building, and you get 52.528, and that's feet. So that's how tall the smaller building will be. Okay, 24, the last one I'll do for this video. So a boat leaves a port and sails 16 miles at a bearing of south 20 degrees east. So south and then go east. So this is kind of the angle we'd actually be at. And that angle is 20 degrees. And it goes 16 miles in this direction. It does it again here, but it goes south and then west, a different boat. South and then west would be here, and then it creates, it's 12 miles at an angle of 60 degrees. And so here's the triangle we have, the outside here, where we have the big angle here would be 80 degrees, and we have 12 and 16. And we're asked to find this opposite side here. So to do that, we're going to be using law of cosines because we don't know the side opposite the angle. So our question mark squared is going to equal 12 squared plus 16 squared minus 2 times 12 times 16 times cosine of 80. This is just using your law of cosine. So if I punch in, and I'll do it in chunks here. I usually do those two chunks first. So I get 400 here minus 192. And so then I do 400 minus 192 is 208. And then we have to square root both sides because this is question mark squared. And so the question mark side is going to be 14.42 miles. So that would be the distance between the two boats. And so the drawing is what most students have trouble with. Once they see that you have the 80 degrees here and how the drawing is set up, using the law of cosine is not too bad. So those are the problems that the student asked me to do to help out on the exam review. So I said I'd post it to just help all the students who have questions on these problems. Good luck, and we'll see you soon.